Okay, in this video we're going to finish off the material for the treasuries, and we're going to start by looking at the treasury auction process. So a few quick details, then we'll look at an example of how an auction would work. First thing is it's a sealed bid process, so you're not going to know what other competitive bidders are going to be doing. You don't know how much they're asking for, how much they're submitting bids for, or what the yield is that they're submitting. So all of that is secret. It's a single price auction, so there's going to be one price that everybody is awarded who wins the auction or who gets some allocation of the securities. There's a set allocation for a particular security. So for instance, there might be a $10 billion auction for 5-year notes. We have these bidders that are broken into two parties. There's non-competitive bidders, which take whatever the highest yield is that's accepted by the Treasury. So they aren't putting in a particular price or a particular bid. They just accept what that result is of the auction. So they are automatic winners, so to speak. So the competitive bidders are bidding on whatever is left of the total allocation after the non-competitive bidders have been satisfied. So again, I mentioned that the non-competitive bidders automatically win, and the competitive bidders are the ones who determine the yield, and that's going to be the stop-out yield. And let's just look at an example of an auction process in Excel. So here I've got some given information. The amount of the auction is $10 billion. There are non-competitive bidders totaling $100 million. So we've got $9.9 billion worth of treasuries to allocate. We've got total competitive bidders, or the total competitive bid amount is $14.25 billion. So that means there's more demand than there is supply. This is oversubscribed. It's got a bid to cover ratio of 1.435. That means there's more bids than there is available securities. I've got a list of competitive bidders, the desired amount, these are in billions, and the yield that they're bidding. Now these are not in order, so one thing I would want to do is to sort these, because the Treasury is going to be awarding based on the highest price offered, which would translate to the lowest yield bid. So for instance, in this particular case, bidders B, the group of bidders that are lumped in as group B, they want a total of $2.15 billion. Their desired yield is 2.1. That's the lowest of these yields, which means they're offering the highest price. So I'm going to go ahead and sort these real quick. I'm going to highlight them, go up here to data, do sort, and I'm going to sort these. Right now they're sorted by the group that they're in, but I want them to be by the desired yield, and I'm going to go smallest to largest. So we've got now these bids sorted in order. So B, the group B, is bidding the highest price, which is equivalent to saying that they're bidding the lowest yield. So they're going to get all that they want out of this auction. There's $9.9 billion available. They're going to get all of their $2.15 billion. And so what I want to do here is kind of keep track of how much is left and how much each group is going to get allocated. So I'm going to start with the $10 billion, and I need to take out the $100 million. So I'm going to take out 0.1. That is the non-competitive bidders. They automatically win. So there's 9.9 available, and the amount that's going to be filled, I'm going to use a little function here. I'm going to use the minimum of the 9.9 that's available, or the 2.15 that they desire. So they're going to get all of their allocation. They're going to get 2.15 billion. And so that means for the next group, there's a little bit less available. There's only going to be 7.75 billion available for those folks. They bid on 3.25 billion worth of securities, so they're also going to get everything that they wanted. Let me go ahead and copy that formula down, and I can march this down all the way, just copying those two formulas. And we can see a couple of things here. First, that the very last group, Group E, they bid on $2.95 billion of securities, but they had the highest yield bid, which translates to the lowest price. So they didn't win. They didn't get any of the allocation. They didn't get any of these securities because the price they bid was too low. The D group, they're the group that's actually setting the yield. They're the stop out yield bidders. So they bid 2.13%, and that's where the allocation or the available amount ran out. So there's no more available after this group. And one last thing to note here is that they didn't get all that they wanted. They only got 1.15 billion out of the 2.55 billion that they desired. So they got the bidders in Group D only got, down here this note, they got 45.1% of their desired amount. So if I was a bidder that was lumped into that Group D, I bid on $100 million worth of securities, and my bid was 2.13%. I'm only going to get $45.1 million of treasuries at this auction. So let's just march through this real quick and make sure we hit all the highlights. The stop out yield is 2.13%. That's determined by the group where we run out of allocation, run out of securities. All non-competitive bidders get their allocation, so those people up there are taken care of. Bidders A, B, and C all get what they want, and they get it basically with this 2.13% yield. They bid a lower yield, which translates to a higher price, but they enjoy the winning yield, and so they're going to be getting these securities at a 2.13% yield. And then we've already talked about bidders D and E. So I want to go back to the slideshow and just march on and talk about some other aspects of treasuries. So let's look at pricing of treasury bills. Remember that these are the shortest term securities sold by the Fed, so these have maturities less than 1 year. They're sold at a discount to par. They're not coupon paying instruments, so they're going to be always sold at a discount. The yields are reported based on this bank discount basis. And the way that formula works, the yield, the quoted yield, is going to be equal to the discount divided by the face value, all multiplied times 360 over T, where T is the number of days until maturity. So for example, let's say we have a $100,000 bill. That would be the face value. It's sold at $99,720. So the discount would be the difference between those two, so $280. It's 3 months until maturity, and in this case that's going to be exactly 92 days. And so if we plug all that stuff into the formula, we get this result of 1.0957%. That's the yield for this 92-day security reported on a bank discount basis. We can do another thing with that formula. We can rearrange things algebraically and come up with the discount. We can solve for the discount if we know the yield, the face value, and the time to maturity. And if we know the discount, then we can figure out what the price for those bonds would be. The price is going to be the face value minus the discount. So let's look at one other example here. How much would you have to pay on a $100,000 T-bill to achieve a 1.115% yield on a bank discount basis over a 61-day period? So if we plug the pieces into the formula here, we're going to have 1.115% times $100,000 face value times the T of 61 days, divide that by 360. Our result is 194.86. That's the amount of the discount. So I would need to subtract that from the $100,000 face value, and the price for this particular bond would be $99,805.14. So if you paid that amount, then you're going to be getting the 1.115% yield over the 61 days. And by the way, that yield is an annualized yield. That wouldn't be the amounts realized over 61 days. It's just the way you would report it. All right, a couple more things here. Quotes on Treasury coupon securities. So as opposed to the T-bills that we just looked at, anything that has a coupon payment, the quotes are going to be priced in basis points, that is the percentage of par, and they're going to be followed by some other units that indicate some of the fractions of percents that are being bid. So 95-12 indicates that the bid is going to be 95% of par plus 12 30-seconds, or a total of 95.375% of par. This thing after the dash here is the number of 30 seconds that are being bid. After, in the second bullet point, this plus sign indicates that they're bidding an extra 1/64th of a percent on top of that 95 and 12 30 seconds. So we've got an extra 64th, which would imply a total bid of 95.390625% of par. And then lastly, if we have a third digit there, that third digit is for the number of 256ths. And in this case, we've got 95% plus 12 30 seconds. And then on top of that is an additional 5 256, which would translate to a total bid of 95.39453125% of par. So very precise bidding in terms of these Treasury securities. Again, that is a reflection of the very high liquidity that these instruments have. And so the last slide here, the last thing to mention about Treasury securities is that we have this notion, this very important part of the market, that is the Treasury strips. So these are coupon-paying Treasury securities. So this happens when coupon-paying Treasury securities are turned into a series of zero-coupon bonds through coupon stripping. So one example of this would be to take a bundle of $100 million of 5-year Treasury notes that have a 2% coupon. And if we break these up into all the constituent payments and make all of those things zero coupon bonds, we could have a series of instruments, series of strips. And the first one would be a 6-month zero with a $1 million payment at the end of the 6 months. That would represent the first coupon payment of this $100 million package of bonds. And again, 6 months later, we could have another zero coupon bond that represents the second coupon payment, the second $1 million coupon payment. And so that, again, would be a coupon strip. We would have a series of 10 of these for a 5-year note, 10 $1 million coupon strips. And then also at the very end, we would have a 60-month zero coupon bond with a $100 million payoff amount, and that would be the principal strip. So we're just breaking down all of the payments from this 5-year coupon-paying Treasury note into the constituent payments and creating basically a zero coupon bond that has that face value. And so that's a very important part of Treasuries. It's an important part of pricing of bonds. And so we want to have this notion in mind, how Treasury strips work, how they're created, and the purpose they serve in the market. So that's going to be the last slide, the last information for Treasuries. We'll pick up in the next set of videos by looking at corporate bonds.